Welcome to aminacademy.com. In numerical methods and analysis of numerical integration, let us discuss about quadrature formula for equidistant ordinates. Here, first consider Newton's forward difference formula. We know that y of x is equal y of x0 plus nh equal y0 plus n into delta y0 plus n into n minus 1 by 2 factorial delta square y0 plus n into n minus 1 n minus 2 over 3 factorial delta cube y0, like the terms are continuing. This formula can also be written in terms of n by u. Replacing n by u, we get y of x equal y of x0 plus uh equal y0 plus u delta y0 plus u into u minus 1 by 2 factorial delta square u delta squared y0 plus u into u minus 1 u minus 2 over 3 factorial delta cube y of 0, then continues. Here let it be equation 1 here. Let us now integrate over n equidistance interval with h. Now we'll integrate. Here the limits are limit of integration we let u, that is x0 and x0 plus nh. Now let here, that is, we can write the integration x0 to x0 plus nh y of x dx we have to find. Now let x equal x0 nh differentiating with respect to that is dx, x differentiation is dx. Here x0 is a constant, so differentiation is 0. Next h du, h and h, which is before that we have, which is x equal x0, n is replaced by u, uh. Now differentiating dx equal x0 differentiation is constant and uh is h du. Here h is a equal space distances. Now we got dx equal to h du when x is x0 and when x is x0, then you can say u equal to 0. And when x equal x0 UH, then you can say u equal n. X0 is NH, x0 is NH, then u equal to n. Now we'll write integration symbol like x0 and x0 plus nh of y of x equal y of x dx equal h is the constant out of integration, and 0 to n, 0 to n y of x0 plus uh du. Now we'll do continuation. H of integral 0 to n y of 0 u, because we are applying x0 plus un uh in terms of difference formula, y0 u delta of y0 plus u into u minus 1 by 2 factorial delta square y of 0 plus u into u minus 1 u minus 2 over 3 factorial delta cube of y0, then terms are continuing with du. Now further h is common. Here we are integrating this all terms with respect to du. Then y0 is a constant, so it gives u of y0 and 0 to n plus each terms are considered. U here u differentiation integration is u squared by 2 u square over 2 of delta y0 from 0 to n plus here u into u squared minus 1 by 2, that is u into u squared minus u over 2 factorial. So we have half take out of integration of this one is u squared integration is u cube by 3, and u into 1 is u into 1 is u, that difference integration is u squared by 2 of 0 to n delta squared y of 0, then plus here 3 factorial is 6, so 1 over 6. Here this is u minus 1 into u minus 2 is u square minus 3u plus 2, and multiplication of u is u cube, like it comes 1 by 1. Now it 1 by 6, then integration of here u cube is u power 4 by 4. Then here next is u term is minus 3u and u minus 3u squared, that is it gives u cube, minus 3u cube by 3 is minus u cube and here next is plus 2 into u. 2u integration is 2u squared by 2, that is u square, with the limits of 0 to n delta cube of y0. Then the terms are continuing. Now further we can write the simplification with like terms and something. We are giving the limits of each terms 0 to n, 0 to n, 0 to n, like it gives 0. If we give n is, it gives n u0, n y0, 0 value is 0. Then here n is n squared by 2 plus n squared by 2 delta y0, and here also 0 values will not affect, n only, so we are replacing n with that. N cube by 3 minus n squared by 2 delta square y0 plus 1 over 6 same n power 4 over 4 minus n cube plus n squared of delta cube y0. Then terms are continuing. This is the integral. Here we can say this one is integral of x0 of, here the limit is x0 plus nh of y of x is the, here this is a called Newton-Cotes formula. This is noted as Newton-Cotes formula for numerical integration. We have done. Please subscribe our YouTube channel.